Hi everyone, today we are going to master one of the most important theorems in geometry, that is the Basic Proportionality Theorem. In short, we say it as BPT. So before we begin with the proof of the Basic Proportionality Theorem, let me state the Basic Proportionality Theorem. So the Basic Proportionality Theorem states that if a line is drawn parallel to one side of a triangle, intersecting the other two sides, those sides are divided in the same ratio. So let's take a triangle and let us name the triangle as triangle ABC. Now, we will draw a line parallel to BC here. So if you see, BC is the base over here, and we shall name the end points here as DE. Now, before we move ahead, just let me mention here that what exactly happens if you draw a line parallel to BC there. So the moment a line that is DE is drawn parallel to BC, it means AD, if you can see here, AD upon DD will be equal to AE upon EC. This is what we require to prove here. So here, mathematically it means AD upon DD is equal to AE upon EC. So this part we are going to take and we shall begin with the proof of this. So the first thing we need to write here is what is given here. So right there, that is triangle ABC with DE parallel to BC there. Next, what do we need to prove? We need to prove that AD upon DB is equal to AE upon EC there. Now, let's begin with construction. So before we need to proceed with the proof, we need to do some construction here. So what we are going to do first here is, we are going to draw a line NE. So a line NE will be drawn parallel to AD here. Sorry, not parallel, it will be perpendicular to AD there. Okay. Now the next thing we will be doing, we will be joining D to M, which is going to be perpendicular to AE, or also we can say AC there. Okay. Once we have drawn these perpendiculars, the next part of the construction is from B to E we will be joining it, and then from B to C we shall join this here. So now your construction part is over. Okay. Now we need to begin with the proof there. So what exactly we have done in the construction, that part we need to mention here. So here one more very important formula that we need to remember is, in order to find the area of the triangle, the formula is half times base times height there. Okay, so I think we are all aware of this formula. And here, area of the triangle AD. So the first thing that we need to do here is, if you see here, the white triangle there. Now we are going to take the triangles which are lying along the side AB first. Okay. So first we are taking the triangle ADE and we'll apply the formula for finding the area there. So the area of this triangle ADE will be half times the base, that is AD, into the perpendicular height. Here the perpendicular height is NE there. Okay. So let's note down here, we begin with the proof, and the same thing we have written here, that is area of the triangle AD is equal to half times AD times NE, which is the perpendicular height there. Okay. Now next is, come along the same line AB, and if you see here, along this base AB lies one more triangle, and that triangle is triangle BDE. So if you observe this triangle, we find that this triangle is an obtuse angle triangle. So remember students, for obtuse angle triangle, the height of the triangle will lie outside the triangle there. So in this case, for this particular triangle BDE, the height will be taken as NE there. So the area of this triangle BDE is equal to half times BD, that's the base, times NE, that is the height of this triangle there. Okay. Now we need to find the ratios of the areas of these two triangles there, that is triangle AD and triangle BDE there. So let us see here. So if you write here the area of the triangle AD upon the area of the triangle BD, this is what we get here. Okay, and if you observe here, let's simplify this further here. So half gets cancelled. Here NE and EN gets cancelled. We'll be left here with, that is, AD upon DB there. So let's write it here. So, and this becomes our equation 1 here. So again I will repeat, the ratios of the area of triangle ADE to the ratio of the triangle BDE will be equal to AD upon DB there, and this becomes our equation 2. Once we have finished with this side here, now we shall move along to the other side AC there. Okay, now here same thing we will do what we have done here for forming equation 1. So here we will now take the area of the triangle ADE again, but this time we shall consider the base as along AC. Okay, so for this triangle the base will become AE. So the area of the triangle AD is half times AE, which is the base, into the height, the perpendicular height for this triangle would be MB there. Okay, next we shall come to this triangle, that is triangle DEC along this base here. Okay, along the line AC there. So the formula for finding the area of this obtuse angle triangle, again I will repeat, for this triangle, obtuse angle triangle, the height of the triangle will lie where? It will lie outside the triangle here. So the area of the triangle DEC becomes half times EC, which is the base, into the perpendicular height, and in this case the perpendicular height is DM there. Okay, so again on simplification we get here, that is the ratio of the area of triangle ADE to the area of triangle DEC will be equal to AE is to EC there. So let us make this as equation 1. Now if you compare here, if you see the numerator here, that is area of the triangle ADE, and in the second equation also the numerator is area of the triangle ADE. Now our major work here is just to prove that area of triangle BDE is also equal to the area of triangle DEC. The moment we are able to show that the area of these two are equal, we will be able to conclude that AD upon DB will be equal to AE upon EC there. Okay, so to prove that these two are equal, okay, that is area of triangle BDE and area of triangle DEC, we just need to remember one very important theorem, and that theorem is, that is triangles on the same base. If you observe these two triangles here, that is triangle BDE and triangle DEC, you will find that these two triangles are lying on the same base here, and the base here is DE. And one more thing you'll notice here, that these two triangles are lying between the same parallel, and the parallels are DE and DC. In that case, we'll be concluding that the areas of these two triangles, that is triangle BDE and triangle DEC, their area will be equal there. So once you have shown, you will be concluding here, let me write this here, that is area of triangle BDE is equal to the area of triangle DEC. You need to mention the reason also, okay, why you are stating that the area of the triangle BDE is equal to the area of the triangle DEC. So here the reason is that is triangles on the same base and between the same parallels have equal areas there. Okay, so the moment you have proved this, we can conclude that AD upon DB will be equal to AE upon EC. So that was a simple proof of the basic proportionality theorem there. BPT is as simple as that. Just compare areas of triangle on both sides, cancel out the common heights, and link the bottom triangles using parallel lines. Made BPT clear and easy for you. Make sure to hit the like button, share it with your classmates, and subscribe it for more easy breakdowns. See you in the next lesson.